Hey guys, how's it going? Jacob here. In today's episode, I'm going to go over some of the basics for what you're going to need to know when you're using RobotC, which is the application that you can use to program when you're using Vex in Principles of Engineering, Computer Integrated Manufacturing, and any sort of engineering class that you may be taking. So, without further ado, let's go ahead and get started.
You've been thunderstruck, thunderstruck. Yeah, thunderstruck, thunderstruck.
And side note, because I don't know how this is going to go, if you hear any sort of background noise, that's because my window's open because I live upstairs and it can get hotter than heck. And my parents are downstairs cleaning the garage. So bear with me. It's going to be fine. It's going to be all good in the neighborhood. So first of all, as you can see here, is the Vex Cortex that you will be using in conjunction with programming. And you see these different ports. Some of them are for motors, some of them are for analog sensors, some of them are for digital sensors. And on there, as you can see, is a place where you can plug in the battery so you can turn it on because it needs the power. And on one part where you can't quite see it because of perspective, that's where you plug in a USB cable so you can then hook it up to the computer so then you can then run code onto it. And as you can see here, this is what a motor and sensor setup looks like for RobotC. And I gotta be honest, I don't have it on my personal laptop, but I do have it on my student laptop, and I didn't want to get in trouble for moving the application over there, so I just took pictures with my phone. But that's not important, disregard that. So here you can see is what it looks like when you're setting up a motor. Typically you're going to be using the Vex 393 motor, and you have the 10 ports. Typically it's a good idea to try to have them in separate ones. Like usually you would do port 1 and port 10 because they're as far away from each other as possible on the Cortex, and it's just good to have good cable management. And now, as you can see, this is what it looks like for the analog sensors, which are, as you can see here, things like an accelerometer, a gyro, a light sensor, those kinds of things. And those are going to be labeled as things like IN 1, IN, I think that says 8. Yeah, I don't have the best eyesight. Here you have the digital sensors, which are DGTL, and it can be kind of hard to read sometimes. I know that I've seen people get confused, but it's fine. And here you have things like a touch sensor, encoders, LEDs. LED isn't really a sensor, but it's something that you can still plug in there. And again, when it comes to just any sort of thing you're plugging into the Cortex, it's just good to try to have as much space between them as possible for cable management. Here is what it looks like when you have picture motors. As you can see, I have them in ports 1 and 10. So what you do to get the motors running is you do start motor, and in the parentheses you have the port that the motor is in and the speed. So I just chose 60. I don't remember what sort of units that is. I'm sure you'll figure it out. It's fine. And I do that for both motors. Otherwise, I just have one going and the robot would be going in a circle, so that would be bad. And then, for good purposes, you need to have a semicolon after it. That's a pretty common thing when it comes to programming because that shows that that line is done. Also, as you can see, it is between two brackets. That determines that what happens in this is part of the main task, or as it's written here, task main. Also, when you first open it up, based on what you're going to need to do, in the upper left hand corner you can see a tab that says robot. You click on that, you go down to platform type, and you need to make sure it is in natural language PLTW because that's where a bunch of these commands are from. And if you're not, then you're going to see all sorts of things that look wrong, and it'll be wrong because you don't have the right language. here you can see is an example of an if statement, and I added in a touch sensor into the digital port 1. So an if statement is if this certain condition is met, then perform this task. If it's not, then you don't do it. You just continue on and maintain the status quo. So I have if sensor value of digital 1 equals 1, which means if that is true, if that button is pressed, then that will stop the motors. So if you have the robot just going along, going at a certain speed, and the button gets pressed, then the motors will stop. Next up, you have a while statement, which is similar, but it's something where it can come out. So here I have a light sensor. So I have the sensor value of IN1. If I have that less than or equal to 2000, then that will set the motor speeds to 30. So the light sensor it picks up on how much light is detected on an object. And I don't remember the range for what it is. So again, I just chose 2000 as an example. So if it gets less than that, then that'll slow it down. But if, say, then the light value goes greater than 2000 again, then that will set them back to 60. And there are multiple other things that you can do in RobotC, but those are just some of the basics. So that's all I really have to say for this video. Not really too long, not really too short. I would say it's just right. So I hope you learned something here. Thanks for checking it out. Make sure to like, comment, and subscribe so you can stay informed on when I'm posting more videos. Make sure to share the video so others can learn as well. Alright, I'll see you next time. Bye.